Next question is very interesting. It suggests that you have to use the algebraic integration and substitution, that is u is equals to square root of x, to find the exact value of sum of the integration that involves all the functions as x. Let me see, it's recording. Yeah, it is. Okay, that's great. So what you have to do, it's given to you that you have to use substitution. Wherever x is used, you have to place it with u. That is the thing that you have to keep in mind. So I can see here is my x, here is my x, here is my x, and here is my x. So every place that contains x, you have to make it u. That's the scenario of this question. So let me see. If my u is equals to square root of x, it means that at this place I can plug u. But what will be the value of this x and this dx? That are the two things that you have to find it first. So u is equals to square root of x. If I apply square on both sides, that gives me square is equals to x. Means wherever the x is used, I have to put u square. What's about dx? Dx is basically the derivative of x. So it would be 2 times u du, which is equals to d of x, right? So dx is equals to 2u du. At every place where x is used, I have to plug its values. So you can see it can be written as 1 to 4 10 over 5 times u square plus 2 times u square of u times by 2u du. Next, what you can do? 1 to 4 10 by 5u square plus 2u cube, by using the base rule of maths. Bases are same, power will be add up, times by 2u du. So you can see 1 to 4 20u over 5u square plus 2u cube du. So what I can do next? 20 is constant, I can take outside. 1 to 4 u dividing by, u can be common from the denominator. So if I took u common, that gives me 5u plus 2u square. This u and this u will make it cancel. Inside I have 20. 1 to 4 1 by 5u plus 2u square du. Further, I can also take u common from it, from the denominator, because I don't have another method to find it. So if I took u common, 1 to 4 1 dividing by u times by 5 plus 2u du. Now here is no other method is present in order to solve other than partial fraction. You have to use partial fraction over here. Okay, so you can see, applying a partial fraction, that is converted into 1 by u times by 5 plus 2u, which is equals to a by u plus b by 5 plus 2u. Hope so you are familiar with partial fraction already. So 1 is equals to a times by 5 plus 2u plus b times by u. What I did over here, because the rule of partial fraction is that the denominator term of the left hand side should be times by each side on the right hand side. So whenever it's time by, then definitely this u and this u will make it cancel, and only the integral multiple 5 plus 2u will be with a. Similarly for b1, 5 plus 2u is present, so write down the term that is not present with b as a denominator, that is u. So u will be times by b. That was the rule of, you can say, partial fraction. So let's compare. 1 is equals to 5a plus 2au plus bu. What you can do next? If you plug u is equals to 0 over here, this term die out, this term die out, and only you have 5a is equals to 1. So a would be 1 by 5. Definitely, it would be 1 by 5. So you get the value of a. Now you have to compare the power for constants over here because there is no other method to find the value. So this is 2au and this is bu. So when you compare the power, means you compare the constants, comparing u terms on both sides. On the left hand side you can see there is only one u term is missing, so it would be 0. On to the right hand side only two terms containing u. One of the term is that one and the other term is that one. So you can see 2au plus bu, right? So you can be taken outside and it gives you 0 is equals to 2a plus b, and after dividing with u it gives you again 0. It means that 2a plus b, which is equals to 0. You know the value of a, that is 1 by 5. So 2 times 1 by 5 plus b, which is equals to 0, and b would be equals to minus 2 by 5. So that's the value of b. Now you got two values that are needed, the value of a and b. So plug back their values into the main integration part. That was this one, equation number 1 for example. So it can see integration of 1 by u times by 5 plus 2u du, and here is outside 20, and it is equals to integration of a by u plus b by 2u plus 5 du, and the limit was 1 to 4 or 1 to 2. Let me see. Limits are 1 to 4. And here is 20 outside. So you can plug back its values over here. So 20, 1 to 4, the value of a is 1 by 5, dividing by u, minus b value is minus 2 by 5. So it would be 2 dividing by 5 dividing by 2u plus 5 du. Make some simplification, it gives you 20 by 5 integration 1 to 4 1 by u minus 2 by 5 plus 2u du. So 5 times 4 make is 20. So it would be 4, 1 to 4, 1 by u du minus 4 times of integration 1 to 4, 2 dividing by 5 plus 2u du. I did nothing, just only apply the integration separately. So integration of 1 by u gives me 1 by 4 of ln of u, and the limits are 1 to 4 minus 8 times, because here is 4 and 4 times 2 would be 8. So you can leave 4 as it is if you want initially. So that gives you integration of ln of 2u plus 5 dividing by 2, and here is 2 as a numerator as it is, and the limits are 1 to 4. So I just find the integration for this 1 by 5 plus 2u, because here the integral multiple of u is 2. So its ln will be ln of 5 plus 2u dividing by 2. Why? Because the integral multiple of u is 2 here now, not 1. It's other than 1. So definitely the integral multiple of u should be dividing with it, other than finding this ln. So when you figure out its ln, it should be dividing by 2. Anyways, now plug back its values over here. That gives you 4 times ln of 4 minus ln of 1 minus 4 times this 2, and this 2 will cancel. ln of yeah, ln of 2 times of 4 plus 5 minus ln of 2 times of 1 plus 5. So hold on your simplification using the ln property and collect the ln terms together. You are able to get your answer in a final form. Let me check. It would be 4 ln of, it would be ln of 4 minus ln of 1 minus 4 times ln of 2. Yeah, this is right. And further hold on simplification to get 4 of ln of 4 minus ln of 9. So other than that, you can use the ln property. It would be 4 times ln of 4 by 9. Not an issue. So that would be your final result. I did this step directly. Just only apply the negative sign inside and hold on similar terms together, and you can get your final answer in this way.